Good morning. Wow. I would have expected the room to maybe be half this size, so thank you for braving the weather. As you know, we have a little storm. I'm Bruce Taylor with Data Center Dynamics, and this morning starts off with a bang. We're doing a couple of things because of the storm that we hadn't anticipated. One is we're streaming live, beginning with this session, and is as much of the content of the conference as we can fit in, particularly on day one. We also will be running a series of webinars covering the content of the conference. So for peers and colleagues who couldn't be with us today, they'll be well served. So, welcome. This is a snow day in New York. One of the things I like to do to encourage people while they're in conference is to do things that they would not normally do. Go to sessions about things you know nothing about. That's the value to me of a conference. It isn't to go and sit in a session where I have high expertise in a subject, but instead go where I have little or no awareness. We're in the era of the zettabyte. We're in the era of digital transformation. Everything that we know about data centers today likely will look very, very differently 5 years from now and 10 years from now. In the era of climate change, a snowstorm in March that is the single biggest storm on record in March in the Northeast should tell you something about what that is. And so we have to be very conscious about how we're running data centers because they are what are going to power Industry 4.0 in this world. So there's a lot to accomplish over a couple of days. Tune in, get together, meet people you don't know. I'm going to introduce Joe Kava now without any further introduction from me about the conference. Joe is the head of data centers for Google, and he has a particular perspective, and the first time I really stumbled across it is at a video by the World Economic Forum on what Google has done about greening its operations. So, Joe Kava.
Thanks very much. All right. So last night, while we were sitting around the bar, as we typically do at these events, someone coined a great catchphrase for the conference, I think, and it's unity through adversity. So we're all here this morning through the adverse weather, and we're still here coming together, so maybe, reach over and give everyone a big hug. So my name is Joe Kava. I run the data center group at Google. That means that I'm responsible for the teams that design, build, and operate all of our data centers worldwide. And I'm going to talk to you a little bit today about our views on sustainability, how we've been working tirelessly to become a 100% renewable energy company, and also a little bit more about how our overall data center program fits into that strategy. It's something that I've been very passionate about since I joined Google 9 years ago, and it's something that we've also realized that many of our customers, they have it as one of their own core values, so it aligns pretty well. So first, taking a look at our network, and let's just talk about just our cloud platform for the moment. This doesn't represent all the data centers, but our network is currently, we're in 6 different regions for cloud platform, 18 different zones. Our network spans over 100 points of presence. We're in 182 countries And just for reference, I think the UN currently recognizes 193 member states, so we still have a little work to do. But this global network consists of our own private fiber, public fiber, our own and leased undersea cables. It's hundreds of thousands of miles of fiber, and many analysts estimate that more than 30% of the world's internet traffic traverses our private network, and that's probably a pretty fair estimate. So that, we think, makes us about the world's largest privately owned network. You know, we've been operating our own data centers for our own product demand for a couple of decades now, and we currently have 7 products that are over 1 billion active users monthly. And to put this in perspective, some of the challenges that come with that and the demand that drives, we're currently serving over 1 billion hours of YouTube every day. 3 billion plus search queries every day, delivered in milliseconds, and over 1.1 billion Gmail users and all the storage that drives. So, I mean, this has just driven explosive growth in the data center demand. You all see this. We all are living it, right? Everything that we're doing every day is driving more and more growth of the networks, the data centers, the storage requirements, and so this fundamentally poses big challenges. Challenges from an energy perspective, challenges from a sustainability. How do you run these businesses in a responsible manner? There is some good news. We, in 2013, helped to sponsor a study that was conducted out of Berkeley Labs, and that at that time they found that if the 86 million US office workers moved their productivity suite, their Microsoft Office suite, their Google Docs suites, if they moved to a cloud, to the public cloud, it would save the equivalent, roughly, of enough energy, enough power to power the city of Los Angeles every year. The savings in dollars are tremendous. The savings in energy is even more tremendous. It is not, I think, a surprise to anyone in this audience, the efficiencies that are gained by moving to the shared public cloud infrastructure over the traditional private enterprise infrastructure. And for us, being environmentally responsible and, you know, trying to run our business, not just for the 3 billion people that have internet access today, but for the next 4 billion people that are going to join the internet community in the coming years. That puts a lot of pressure on us. How are we going to do that in a responsible way? So I've talked extensively. I'm going to run through very quickly some of the best practices, because your sustainability, your efficiency program, even if it's a renewable energy program, it has to start with the same kind of 3 R's that we learned when we were learning to recycle as children. It's to reduce, reuse, and recycle. So the first R is to reduce, and that's where the energy efficiency program comes into play. I've been talking about this a long time. You've heard me, so I'm not going to belabor this, but it really does come down to kind of the same best practices that we're all very familiar with. You know, we believe that the best energy saved is the energy not consumed in the first place. That's why we have been so laser focused and relentless in our pursuit of reducing our PUE. It's not simply just because we wanted to post nice numbers up on our website every quarter, but it's because it makes a huge difference in the amount of overall energy consumed. And at our scale, it's tens of millions of dollars a year in energy consumption. So forget from the altruistic, oh, it feels good to be green and all that. It does. it also feels pretty darn good to have a really solid balance sheet. So, speaking of our PUE, right, we've, I think, kind of reached a level where it's stable. And what we've done, I'll talk a little bit more about how we've applied machine learning to help kind of go past that plateau. And really what that's done is it's enabled us to expand many, many, many more cloud regions, which are typically much smaller than our hyperscale, large, massive data center campuses. So now we can, through the aid of our machine learning, we can also achieve similar types of really very, very efficient compute infrastructure, even on much smaller scales. And that's always been one thing that has been difficult for for industry operators that are running at a smaller scale. It's like, okay, how do you get a 1.1 PUE when you're only running a 1 megawatt site or something like that? Well, the machine learning algorithms that we've developed have really given us a lot of insight into that. I'll talk a little bit more about it. I've also, we've been talking over and over and over again about, wear shorts in your data centers. It's cool to be warm. So we run our data centers at nominally 80 degrees Fahrenheit. So that's our cold aisle temperature. And it really, it's the first step, right? Just turn up the thermostat. Use free cooling. We've talked about this over and over. Whatever way, water side economized, air side economized, whatever. Use the natural environment to the greatest extent possible. We've done everything from seawater cooling to industrial canal water cooling to gray water recycled, rainwater harvesting, stormwater recapture, reuse. All of these things are possible, so just use the natural environment to the greatest extent possible. We've also invested a pretty large group in modeling, thermal modeling. So our team of engineers back in Mountain View work all the time to make sure that we're appropriately sharing air resources, we're managing our airflow, and that we are eliminating any potential hotspots. And that has become more challenging and more imperative, frankly, as machine learning has started to really take off. And I know that Christian has the same challenges because these platforms are typically running on GPUs. These are, maybe NVIDIA or AMD GPUs, and they run hot. They consume far more. So now, we've been talking as an industry about those 30 kilowatt cabinets and 40 kilowatt cabinets. Well, now it's starting to be much higher than that. We've optimized the actual hardware, right, so that we are not building in any unnecessary components. Our servers aren't sold to the mass market, so they don't have to include a lot of the extra chipsets, drivers, video cards, things like that. So these are just bare bones. So we don't build it in if we don't need it. We've also worked a lot on optimizing the electrical path, reducing the number of transformations, making a common voltage motherboard, these types of things. But recently we've also taken some of our learnings on our 48 volt DC rack system, and we've contributed that to the Open Compute program. So good for us, good for the industry. If we can drive some standards through the OCP, that helps everyone. So. And as I was talking about our machine learning, we're now working on a fully automated program. So just like kind of the driverless cars went from a person behind the wheel, but taking your hands off and being there just in case, that was our first machine learning algorithm where the operators would go in, run the algorithm, and get the recommendations, and they would go and set up the plant. Well, now we're developing a fully automated real-time response system so that the plant is optimizing itself all the time based on these machine learning algorithms. So it's, you look at that, and that is reflective of kind of our best data centers where we've achieved just from the machine learning. And these are data centers that are already operating at like only 12% overhead. They've been able to reduce the cooling overhead by 40%. just using the insights that come from these machine learning algorithms. So it's really powerful. And we're starting to see almost every customer, every type of industry use machine learning to find insights in their business. And this is, I think, probably one of the biggest drivers of internet infrastructure and data center demand in the next decade is going to be machine learning. It really changes everything from medical diagnosis to automotive parts failures. And so every industry is looking at how to employ machine learning. Okay, so our journey towards sustainability. It's been a long road, and it's something that we've been deeply committed to long before I got to Google. Larry and Sergey had these as part of their core values. And so we've really, everything from the way we design our offices to the materials that we use in our offices, and of course our data centers, has a view towards a sustainable business and a sustainable economy with that. One of our initiatives that we took on as a big challenge is a zero waste to landfill initiative. We have committed that we will have 100% landfill diversion for all of our data center operations globally. So far, we've achieved that at 6 of our campuses. So 6 of our operating campuses have 100% landfill diversion. So it's not just about the energy savings and renewable energy and things like that. It's also about your waste. And every hard disk that is destroyed, every tape drive that is shredded, all of those are recycled, they're diverted. All of our batteries are 100% recycled. Even the ones that you have to pay for to be recycled. A lot of times people will pay you for like lead, but they won't pay you for lithium ion right now. So some of them, I think that business is starting to come around. But regardless, 100% of that is recycled and diverted. We also are big believers in the circular economy. We're partners with the Ellen MacArthur Foundation on circular economy. You might wonder what this robot has to do with the circular economy. Well, that robot goes in circles. Really, that is a fully automated disk erase environment that is in all of our data centers. That allows us to process at a much higher throughput all of our hard drives so that we can verify that they're erased, and if not, we divert them to be destroyed and then recycled. But once they're fully erased and verified clean, then they are resold onto the secondary market. And so this is that reuse that we were talking about, second R. So we resell. As a matter of fact, in 2015, 19% of all the servers that we deployed worldwide were remanufactured servers. 52% of the components that went into server repairs and upgrades were reclaimed, reused components from other servers. So we really are trying to push the boundaries within our business model of what we can do to reuse and kind of refurbish. And this year, we're going to hit 100% renewable energy. That means that for every unit of energy consumed in 2017, we will have purchased an equivalent amount or an equivalent unit of renewable energy, not just for data centers, but for all of our operations worldwide. So as you can imagine, that's a lot. It's a lot of energy. So how much? 2015, Alphabet was 5.7 terawatt hours. Just think about that. 5.7 terawatt hours was our energy consumption, which was just shy of the city of San Francisco's total consumption for the same year. So you can tell that it creates a big bogey if you want to be 100% renewable, and that's your footprint. And by the way, data centers make up the vast majority of that 5.7 terawatt hour consumption, right? So it's a huge challenge. How do you do it? Well, the way that we've been approaching this since 2010 is through these large power purchase agreements. These are wind farms and solar farms that we go out and we purchase directly. So far, we've done 20 deals. It's the equivalent of 2.6 gigawatts of renewable energy that we have contracted for now. And these projects, they also drive a tremendous amount of economic development as well. So far, the projects that we have contracted for have driven $3.5 billion of economic development activities just to develop those projects. And 80% of that has been here in the US. So our new president would be really proud of that. And along the way, that makes us the world's largest corporate purchaser of renewable energy by a pretty wide margin. But what I'm really pleased to see is that if you look at the efforts of a lot of our peer companies here and some other companies in other industry and business sectors, the amount of renewable energy projects that have come about has just soared. What we're seeing is we are seeing economics in action. This is when customers say, I want to buy this product. It's not available today, and whoever can provide it to me is who's going to get my business. And guess what? The suppliers start to respond. They start to build products that consumers want to buy. And it's clear to me that corporate consumers are interested in buying renewable energy. So a little bit about the details of these constructs. We go and we purchase these large power purchase agreements on the wholesale competitive market. We purchase, this is important, we purchase the physical energy, the physical renewable energy, and the renewable energy credits bundled together. We don't go out and just buy unbundled renewable energy credits. We are buying the physical renewable energy. That means that it's additional. It's additional onto the grid that didn't exist before, and but for our investment would not have existed because the developer did not have the financial certainty to undertake that project. But we enter into long-term fixed price agreements on the wholesale unregulated market. We then sell back into the overall grid. So we sell back into the spot price wholesale market. We sell that renewable energy that we just bought with those credits. We sell the renewable energy, we keep the credits for ourselves. And then our data centers are just consumers from the grid. So whoever the utility provider is in that particular region, we buy directly on the regulated market from the utility providers. And then we apply those renewable energy credits that came from that power purchase agreement. We apply those to our consumption from the grid. And that's how, by the end of 2017, every unit of energy consumed worldwide will have been offset with a renewable energy project like this. And as I mentioned, our data center operations, they account for the majority of our total carbon footprint. And I think that we all agree, and it's part of our core values and our beliefs, that the science of climate change is irrefutable. So it's imperative that we start to act, and we want to also not just do this for us. We want to provide the constructs, and we want to provide the kind of the utility business models. We want them to change so that they can be more consumer-centric, more customer-centric, and they will start to provide what customers want to buy. And sometimes that means that we have to go out and help some of the regulations along the way and move the needle a little bit. And so we've been definitely committed to doing that. As I mentioned, this is good for business also. On the operating cost side, electricity consumption is a major component of our total operating costs. I mean, besides depreciation from your assets and servers and all that, it is the next most highest cost driver in your OpEx, or our OpEx anyhow. And so having these long-term fixed price contracts and the certainty that comes along with that is really good for our business predictability as well. So it's not just the right thing to do. It's not good just for changing the market, but it's also really good for business. And I talked a little bit about that. And I talked about the economic development that comes along with that. You know, as I mentioned, over $3.5 billion of economic development activities because of the PPAs we've signed. So that makes a big deal. It drives job creation. So the renewable energy market, I was reading that wind power, the job creation in wind power in the United States will eclipse manufacturing jobs in the United States. So, I mean, it's huge. It's I think, one of the next big industries, especially if we, maybe not our industry, but some of our tangential industries, if we can figure out the grid energy storage equation, then we really have a shot at totally greening the grid. Right now, we use the grid overall to firm and shape our power that we buy, right? So we put the renewable energy onto the grid, but they're intermittent. But then the rest of the energy generators on the grid firm and shape the power delivered. So if we could do that with grid level, really efficient, very cost-effective energy storage, then we can really, I think, fundamentally change the US grid, which is way too old. And along the way, we've been trying to drive the industry forward with our work on the public policy side and our work with NGOs. We've made some really good strides in areas where the option to buy renewable energy wasn't available before. You know, the green energy tariffs that we've worked out, even some of the international new energy policy, like in Taiwan. Buying renewable energy in Taiwan wasn't possible before, and now, thankfully, through the work of our policy team and the local government there, they've passed a new energy regulation there that allows customers, consumers, to now buy renewable energy on the local market in Taiwan. So this is not just good for us, right? It's good for anyone. These are not things that only help Google. These help everyone. We've received some pretty high marks and accolades from people along the way. In 2017, Greenpeace's Clicking Clean report, we got a final score of a grade of an A. One of the only 3 of the 15 companies they evaluated got A. So, you know, it's nice to be recognized also. So, there's a lot more work to be done, though. It doesn't stop here. Ultimately, we want a 100% zero carbon grid for everyone. There's a long way to go before we get there. So the work hasn't stopped. It's a journey. It's been a long journey for us so far, and there's a lot more to come. But this is our ultimate goal, and we will keep working at this until we can say that we are buying in every region, real time, 100% zero carbon energy directly from the grid. So, thank you all.